Hi everyone, welcome back to the channel. So today we will be discussing about deadlock avoidance. That is very important topic, and one important method that helps to avoid the deadlock, that is the Banker's algorithm. So these topics are very important for our exams. So let's start with the introduction. As you can see here, in deadlock avoidance, the request for any resource will be granted if the resulting state of system does not cause deadlock in the system. So let's take an example. Let's say we have two processes and one resource let's say CPU. Here the deadlock avoidance, the request for any resource. Let's say process P1 is requesting for resource CPU, and the resource will be granted. Its request will be granted only if the resulting state does not cause deadlock. That means the CPU will be allocated to process P1 only if process P1 is not currently holding any other resource. अगर मान लीजिए कि प्रोसेस P1 ने अभी किसी भी रिसोर्स को होल्ड नहीं रखा हुआ है, वो बिल्कुल फ्री है, तभी CPU प्रोसेस P1 को मिलेगा. ठीक है. उसी तरीके से एक और एग्जांपल लेते हैं कि मान लीजिए प्रोसेस P2 भी CPU के लिए रिक्वेस्ट कर रहा है, लेकिन प्रोसेस P1 करंटली रिसोर्स R2 को यूज कर रहा है. दैट मीन्स इट में कॉज अ काइंड ऑफ डेडलॉक. सो इसमें क्या होगा, हम डेडलॉक अवॉइडेंस टेक्निक के अकॉर्डिंग इसको रिसोर्स अलॉट नहीं करवाएंगे. Okay, so this is the definition. In deadlock avoidance, the request for any resource will be granted if the resulting state of system does not cause deadlock in the system. In simple terms, you just have to remember two things. First thing is safe state, and another thing is unsafe state. Remember one point, in case of operating system deadlocks, whenever we talk about safe or unsafe states, that means we are directly talking about only deadlock avoidance. Okay, in case of deadlock prevention, we does not talk about safe or unsafe state. Already we have discussed. Remember this diagram. Okay, this will help you understand the concept of safe and unsafe state as well as the concept of deadlock. Okay, so here we have safe state and here we have unsafe state. Under the unsafe state, deadlock is always there. Okay, so in case of deadlock avoidance, अगर हम देखते हैं कि फ्यूचर में डेडलॉक होने के कोई भी चांसेस नहीं है, ठीक है, सिस्टम बिल्कुल सेफ स्टेट में खेल रहा है, तो ही हम रिसोर्स एलोकेशन प्रोसेस को फुलफिल करेंगे, किसी प्रोसेस की रिक्वेस्ट को फुलफिल करेंगे, अदरवाइज वो कंप्लीट नहीं होगा. ऑलराइट, वन मोर डेफिनेशन आई वुड लाइक टू शेयर विद यू. The deadlock avoidance method is used by the operating system in order to check whether the system is in safe state or in unsafe state, and in order to avoid the deadlocks. In order to avoid the deadlocks, the processes must need to tell the operating system about the maximum number of resources a process can request in order to complete its execution. In simple terms, we can say if you want to avoid the deadlock, then the processes must tell in advance their maximum needs. Let's say process P1 wants CPU for 10 minutes. Process P2 wants CPU for 4 minutes. Okay, if processes tells their requirement, their needs in advance, then it is possible to avoid the deadlock. All right, so this is very important and basic definitions. I hope everything is clear. If you have any doubt, you can comment below. I will definitely help you all. In this method, in this deadlock avoidance method, the request for any resource will be granted only if the resulting state is safe. This method checks every step. This is a step-by-step method here. This method checks every step performed by the operating system, and any process continues its execution until the system is in safe state. जब तक सिस्टम सेफ स्टेट में नहीं आ जाता तब तक उसके एग्जीक्यूशन को वो कंटिन्यू करेगा. Once the system enters into an unsafe state, the operating system has to take a step back. Okay, this is safe state, safe state, every state is safe here. Let's say here the operating system is going to fulfill the request of this process, and उसको पता चल गया कि अनसेफ स्टेट है, तो ये क्या करेगा, एक स्टेप बैक ले लेगा ताकि डेडलॉक में सिस्टम फंसे ही ना. ओके, so this is all about deadlock avoidance. Now let's just talk about deadlock avoidance technique, that is Banker's algorithm. So every time remember one point, one numerical questions will be asked in every examination. So in this video we will discuss only theoretical section of Banker's algorithm. So it is a deadlock avoidance algorithm used in operating system. It was proposed by Dijkstra in 1965, and the Banker's algorithm works on the principle of ensuring that the system has enough resources to allocate to each process so that the system never enters a deadlock state. Remember one point here. Okay, Banker's algorithm हमें कहता है कि बैंक में कैसे काम होता है. लेट्स से देयर आर 3 पर्सन जिनके बैंक में अकाउंट है, सेम बैंक में, ठीक है. पर्सन ए को 3 लाख का लोन चाहिए, पर्सन बी वांट्स लोन ऑफ 2 lakhs एंड पर्सन सी वांट्स लोन ऑफ 6 lakhs. ओके, इन्होंने क्या किया, बैंक मैनेजर को एडवांस में ही अपनी रिक्वायरमेंट्स बता दी. अब बैंक मैनेजर बोलते हैं कि हमारे पास वी डोंट करंटली हैव 2 lakh, 3 lakhs और 6 lakhs. We have only 1 lakh right now. Okay? We only have 1 lakhs right now. So ऐसे में क्या होगा, किसी की भी रिक्वायरमेंट को फुलफिल नहीं किया जाएगा. तो अगर मैनेजर को पता है कि उनके पास किसी की भी नीड को फुलफिल करने की अभी कैपेबिलिटीज नहीं है, सो वो क्या करेंगे, वो सेफ स्टेट में ही रहेंगे, वो जबरदस्ती किसी को लोन नहीं देंगे एंड अनसेफ स्टेट में नहीं जाएंगे. ठीक है, ये होता है बैंकर्स एल्गोरिथम. अगर उनके पास 2 lakhs होते तो वो पर्सन बी की जो रिक्वेस्ट है 2 lakhs वाली, तो उसको फुलफिल जरूर कर देते. But they don't have 2 lakhs, they have just 1 lakh rupees in their account. So इसीलिए वो सेफ स्टेट में रहना चाहते हैं और डेडलॉक को अवॉइड करना चाहते हैं. So this is the basic introduction to Banker's algorithm. Okay, so every time you have to check, in case of Banker's algorithm, every time you need to check the processes P1, P2, P3, let's say, their maximum need. This is the introductory lecture only. We will discuss a numerical question in next video. Okay, maximum need for P1 is 10, P2 is 4, and let's say P3 is 9. Okay, and their current need, that means how much amount they currently want, they currently need, 5, 2 and 2, right? Means maximum need of P1, let's say a person A wants 50,000 rupees. उन्होंने मुझे कहा लोन के लिए, बट मैंने बोल दिया कि मेरे पास तो नहीं है, तो उन्होंने कहा ओके. मैंने बोल दिया कि आई हैव ओनली 10,000 रुपीज. सो उन्होंने कहा ओके 10,000 दे दो, 40,000 आई विल अरेंज फ्रॉम समवेयर एल्स. सो दिस इज द करंट नीड. 10,000 जो उनको मुझसे उस वक्त चाहिए, दैट इज द करंट नीड, एंड देयर मैक्सिमम नीड इज 50,000. ओके, सो दिस इज हाउ Banker's algorithm work. So this is the basic criteria. I hope everything is clear till now. So good luck everyone.